In the previous video, we had read about the evidences and finding of Rutherford model of atoms. In this module, you will learn about its drawback and the Bohr's model of an atom. Before Bohr, many scientists worked on atomic structure. I mean, various models of atom have been proposed by the scientists. They would do experiments and disprove the models, and then again they would propose a new model. This model have increased our understanding of atomic structures. So, let's revise again various models. It all started in 187 where Dalton proposed the model of atom where he considered it as a solid sphere, so just like a tiny ball, a tiny sphere. And this model was there for many years. In 1897, J.J. Thomson proposed a new model of atom. After the discovery of electrons, this was called the plum pudding model of atom, where the atoms were thought to be large positive sphere, and in that these tiny negative charge electrons were embedded like plums in the pudding. But this model was disproved by the Rutherford when he did his famous alpha scattering experiment. And he said that the atom does not contain a large positive of charge, rather, the positive charge is concentrated in a very tiny area called the nucleus of atom. And that's why this came to be known as the nuclear model of atom. And the electrons are spinning around this nucleus. But then there were drawbacks of Rutherford model, and then Neil Bohr came up with a new model of atom which is called planetary model of atom, where electrons revolve in the certain shells, and Rutherford model was closer to the Bohr's idea. So we will talk about the drawback and Neil Bohr model of atom. Rutherford model showed electron revolving around a positively charged nucleus in well-defined orbits. But there was a problem with this. The motion of electron in his model was unstable. Any particle moving in a circle or a circular path emits electromagnetic radiations. Thus, the electron would lose energy and fall into the nucleus, making atoms collapse. But hold on a second. These things doesn't actually happen inside an atom because in nature all the atoms are stables. Rutherford atomic model, which he explained, was quite commendable, but it was not theoretically entirely correct. So does that means Rutherford hypotheses were also incorrect? No, that's not the case. Those hypotheses just needed a few modification. Then which would be the better model of an atom? To overcome the objections against the Rutherford model of atom, Neil Bohr proposed a new model of atom. Neil Bohr proposed a new model of atom. He provided additional explanations to describe the atomic structure. The postulate included by the Neil Bohr were as follows. First, there are certain special orbits called discrete orbit in which electrons are allowed inside the atom. Second, when electrons move in this discrete orbit, they do not radiate energy. Now, these points tell us why the atom remains so stable. But what about the paths or orbit in which electrons revolve around the nucleus? Let's understand this with an example. Do you know what our solar system is like? It looks something like that, right? Now the sun is stationed at the center and the planets revolve around it. But have you noticed that the planet always move in a fixed path? We never see a planet suddenly jumping into a different path, right? They always orbit the sun in well-defined paths. In the same way, our atomic structure works. The nucleus is like the sun at the center, and the electrons are like the planet moving in a fixed defined orbits. These electrons orbits are called shells or energy level. Now, the energy level brings us to an important concept. Neil Bohr suggested that the electrons revolves around the nucleus in a specific orbits, and these orbits are associated with the definite energies and are called shells or energy levels. These shells or orbits are represented by the letter K, L, M, N, or by the numbers 1, 2, 3, 4. It's simple. Starting from one closest to the symbol, we name them K shell, L shell, M shell, and N shell, and so on. Yes, KLMN. And with all these theories and points in the mind, we now know the structure of an atom. The nucleus contains the positive protons and the electrons moves in the fixed orbit. So is that all for the structure of atom? No, it's not. We still have one more subatomic particle left. What it could be, and where could it be found? Let's find out. In 1932, Sir James Chadwick, a famous English physicist, discovered this third subatomic particle. He found the particle mass was roughly equal to the proton. And what about their charges? Generally, they had no charge at all. Yes, these particles were neutral. Later, these particles were named neutrons and they were denoted by the letter N. Now we have the complete design of the atom. Positively charged protons and neutrons at the center of the nucleus, while negatively charged electrons orbit around the nucleus in fixed orbitals. But how exactly are electrons distributed in these orbitals? Is there a way to find out the maximum number of electrons in each orbitals, or are they randomly spread out? Let's find out the answer to these questions in our upcoming videos. Till then, see you and thank you for watching.